Hey, how's it going guys, DIZARO here, and today we're getting back at our project. Today we have two main topics, game objects and an introduction to coding. I'll give you a few Unity tips and a few good explanations that might help you create your own game. If a game were a band, game objects probably would be band members. Without them, there would be no band. So if we put band members together, they'll make music. In the same way, if you put game objects to interact with one another, you get a game. Basically, game objects are the objects that exist in the scene view and can be accessed, grouped and found on the hierarchy and modified in the inspector. Game objects only differ from one another from the components that added to them and eventually make them up. If you give a drum set to a band member, he'll be a drummer. Guitar, he'll be a guitar player. It's the same for game objects. Let me show you a practical example. By dragging an asset from a project view into a scene view, a game object is created, as you can see here. I first change my game view resolution from 3 aspect to standalone. This way, I can see the game view in the same way as someone who plays a game in a computer. If you go to the hierarchy and right click on it, this list will pop up and you can then perform any of those actions. Rename, duplicate, delete, or create different game objects from the listed presets here. I'll go with create empty. As you can see here, a new game object was created and the spec only shows it transformed, hence it doesn't have any other components and the transform component is a default one. Every game object has a position in a 3D world, it proves that it exists. In this case here, I right clicked an existing game object and then created a new empty one on top of it. That makes the new game object a child of an initial game object. It's basically grouping stuff. If something happens to the parent guy, it will happen to the child. If the parent moves or is destroyed, the same will happen to the child object. You can then create child objects to the child objects, and an initial parent will become a grandparent. To quit this parenting relation, just drag the child object out of the parent one. As you can see, the only thing that changes from one game object to the other are the components that make them up. Lights probably have a light component, spheres have meshes that make them visible and round, they have physical components that allow them to collide to other game objects, and so on. Unity gave us these little toggles that lets us perform changes to these game objects in a simpler, much more dynamic way. The hand toggle lets us move the scene view, not the objects, just the view. The cross arrow one lets us move the objects in the 3D world, and you can choose if you need on a specific axis or freely by clicking on this square corner. If you hold down Ctrl or Command if you're on a Mac, it snaps the object. And the same goes for the other toggles. The round one lets you rotate the object. The next one lets you scale it. And the rect tool lets you manipulate your object if it had a rectangle on it. It's great for 2D and UI. And the last option is basically the mix of all previous. The shortcut for these to use are Q, W, E, R, T, Y, in the same order as it appears in Unity. By modifying a component's parameter in the inspector, you modify something on that object. Unity now lets you save or load presets by clicking here, or organize them by clicking on this icon here. And if you have any doubts, just click on this little book here. It opens Unity's documentation on that subject. The list of components is quite vast. You have multiple different components that work in specific ways but can produce unexpected results. Mess around with them. Change the parameters, play the game and see the results. Change it again, look the specific parameters on the documentation. Create standard game objects. They come with components already added, so it gives you an idea of how to work with them. Look stuff up on the asset store, study other people's work, either there, on the community, or Stack Overflow. Mess around with them, it helps. Scripting is a way to perform dynamic changes to game objects, to the editor, to the devices, or even Unity. You can access different components, create new stuff, or delete other stuff. You get to tell the game what to do and how. You can create a folder to put in all of your scripts. After you do that, you right click within that folder in the project view, go under create, then select script, or you just go under the tab create and do the same thing. Rename it and double click it to open up. If there was a typo on the name in the script file you just created, or you just want to change its name, you must open up the file and change the class name as well, otherwise it will give you an error. After your scripting editor opens up, you see this format here. This is your script. The start part here is the libraries you're using. Libraries are just a collection of code built in that you can use to make your life easier. There are a few functionalities in Unity that you can only access by adding a new library here. After that, you see the class. The class is basically the blueprint for all your objects. It tells you what characteristics, properties, functionalities a determined object can have. All instances of that class will have the attributes determined by said class, but they change from object to object. Let's say you have a 2D game that has multiple enemies. All of those enemies will have health point counters to tell if the enemy is dead or alive, and a special ability to perform an action, either an attack or defense. With the same class enemy, you can create a mummy and a vampire. Both of them are enemies, and both of them will have health points and a special ability, but the amount of health points and what special ability each one has different from object to object. That's what classes are for. Every script created by Unity has MonoBehaviour as a parent class. I'm not going to detail now, but keep in mind that MonoBehaviour allows you to access most of the functionalities a GameObject may have. MonoBehaviour is a base class for Unity, and it tells the engineer dealing with Unity stuff. That's something for another day. Just don't delete MonoBehaviour and carry on writing your code. As I said, MonoBehaviour lets you access a bunch of stuff, and that includes two methods that come with the class: start and update. Basically, the start method lets you do a series of things as soon as the game starts, and update, well, it updates. It will loop every frame and repeat whatever is inside of it. Now that we understand how it works and what it does, let's go back to our enemies example to show it working before jumping back to our game. Right below the class name, we're going to write public int health point and public string special ability. The public keyword's not new for us, we've seen it in the class definition. It means all the classes can access that information. If you don't want it to be public, you may omit that part or type in private instead. There's also the protected keyword that lets derived classes access that information. It's like a family secret. If it's public, everyone may know. If it's private, only you can know. And if it's protected, your family knows, but they won't tell us so. The int keyword tells the engine that we're dealing with integer numbers. Whole numbers, 0, 5, 255, minus 64, all of those. If we want mass real numbers, we'd use float numbers. So we'd have 4.5, 16.0, 5462. Just don't forget the F. C# needs it. If the number's too big, you also have other keywords out there. Google it. The string keyword tells us that we're dealing with string of characters, so we can have anything written there. It saves the text with letters, numbers, spaces, special characters, and so on. If we save the file as is and go back to Unity, we must add the script we just created to a game object. And remember this part, it's really important. You can drag the sprite as I taught you in the previous tutorial and create two different game objects. Rename them to vampire and mummy according to the image they have, dragging the script to the game object, either in the hierarchy or the inspector, or click add in the inspector and choose the right script. The inspector will show all the attributes the enemy has. You can increase its health points by typing in a value or by clicking the attribute's name and dragging it up or down or right or left. Then you type in a special ability. Do it for both enemies, and if you play your game, guess what? Nothing happens. That's only because you've not performed many actions, just created the stuff. Go back to script and type in the start method, debug.log, gameobject.name. That gets the object's name in the inspector, plus health points. And then debug.log.name plus special ability plus special ability, like I've written here. If we play our game now, it will display it in the console. This tab right here. There. If you change it, you have to play it again to get it updated. Or we just cut this from the start method and put it in the update. Now, whenever you change its value in the inspector, we'll change it in the log. But that's not fun. Let's create something fun. Let's say the enemies are going to fight each other, and the one with the bigger health point wins. Yeah? Then the one that loses is going to get all red, because red means he's dead. To do so, we go back to our update method, so it gets checked every frame. If health points less equals than 0, Gameobject.getComponent sprite renderer .color equals color.red. Well, that's a big syntax, isn't it? But what does it mean? Well, that's an if statement. It checks for a condition. In this case, health points less equals 0. If that condition is true, whatever is inside the block of code will run. So we get in the sprite renderer component in our game object, either the mummy or the vampire or any other, because this is a blueprint, and we change the property color of setComponent to red. So by doing so, we can access stuff in the game objects in which a script is located, and we can modify it. But now, how do we compare both game objects' health points? Okay, I mean, it changes the color if the health point is less equals 0, but how do we compare it? Now we create another script. Call it whatever you're feeling like. Doesn't matter. I'll call mine comparer, because it compares stuff and I'm quite creative. I'll put it in the main camera. I'll open up the code and I'll type in public game object vampire and public game object mummy. Just like string, int, float, char and any other keyword, we can access objects of different types. We can access game objects, main cameras, animators, rigid bodies, and so on. We just created an instance of that type. If you go back to Unity, our script on the main camera now shows 2 slots of game objects. That happens because they're public variables. If we omit one of them or change it to private, it won't show in the inspector. Anyways, objects. You may click on that dot and choose the game objects or drag in from the hierarchy. After we assign, we must compare them. So we go back to our compare script, and in there we type in the start method. If mummy.getComponent of type enemy .health points bigger than vampire.component of type enemy .health points, because in this case we're accessing these fields here. Vampire.getComponent of type enemy .health points equals 0. By changing the vampire's health points to 0, the enemy script condition will be true and we will change the color to red. But if the mummy health point is less than the vampire's, the mummy's color should change. To perform so, we just add this else statement. Mummy.getComponent of type enemy.health points equals 0. That means that if the condition in the if statement is not true, whatever's inside the else code will be executed. If we play this and mess with the values, we get different results as so. We given conditions to certain variables that we've created and modifying components found in game objects. If we want to check for more than one condition, as if the health points were the same, we could by just adding a bit of code, like else if vampire.getComponent of type enemy.health points equals mummy.getComponent of type enemy health points. Both of them get red, and we display this message here. And to make your guys' lives easier, you might as well create instances of the enemy class that access the enemy script directly, and you just tweak stuff and clean a code. And that's it guys, for today we're done. But we'll talk a bit more about coding in the next video. And then we're coding our game, finally, innit? But I hope you guys liked this video. The Unity tutorials are going great. I loved the previous one. You guys seem to have liked it as well. And thank you for the support. It's been an amazing journey. Please like this video, subscribe, share this, start making your games, and see you guys next video.